Dear students, welcome to today's class. So, in yesterday I have explained about period and periodic nature of various trigonometric functions. Okay, now I hope that you understand that class. Today in this class I am going to explain few more concepts regarding periodicity of a trigonometric functions. So, let us start our class. So, here the first thing is, if the period of a function is p, then the period of the function f of ax plus b is p upon modulus of a. What is the meaning of this, sir? For example, if f of x is equal to sin x, f of x is equal to sin x, what is the period of sin x? As already we showed that 2 pi. What is the period of sin x? 2 pi. Now, if another function is there, f of sin 2x, that is f of 2x, what is the period of sin 2x? This is nothing but 2 pi upon what is the coefficient of x? What is the coefficient of x? 2. That is equal to modulus of 2 we have to write down. 2 pi by 2, 2 will get cancelled, pi. Therefore, sin of 2x period is pi only. Okay, now next one more example. If f of x is equal to, one more example, if f of x is equal to cos 3x by 2, f of x is equal to cos of 3x by 2. What is the period of cos of 3x by 2? We know the period of cos x is equal to 2 pi upon what is the coefficient of x? 3 by 2. That means modulus of 3 by 2 is 3 by 2. So, this is equal to 4 pi by 3. Understand this concept? So, that is the examples for that concept. The next concept is a very important concept. Let us see the second concept. So, dear students, here you see here C1 f1 of x plus or minus C2 f2 of x upon C3 f3 of x plus or minus C4 f4 of x. Here C1 of x, f1 of x, f2 of x, f3 of x, f4 of x are any functions as you like. Okay, so they are separated with our plus or minus or whatever may be that. Then the period of that function g of x is equal to LCM of the periods of the all these four functions. Here C1, C2, C3, C4 are constants. For example, you are given like this one function. So, you are given one function f of x is equal to, so this is equal to sin 2x by plus cos x upon cos 2x minus sin 2x. You are given one function like this. So, if you want to find out the period of that function f of x, so what is the period of the function? F of x is equal to, find the periods of each and every function. Find the periods of each and every function. Take their LCM. That means LCM of, what is the sin 2x period? Just now we have seen pi. What is the cos 2x function? 2 pi. What is the cos 2x function? Pi. Sin 2x pi. So, you have to take LCM, that is equal to 2 pi. 2 pi is your answer. That means, whatever may be the function given, whether it is a multiplication or division or whatever may be that, if it is a addition and subtraction of any more functions, 2 or more functions of trigonometry or any functions, take the periods of each function separately, find its LCM. That least common multiple will give the period of the whole function. Okay, now. So, I hope that you understand that concept. Now, coming to the third one, very easy one. If f is a periodic function, then the negative of f, that is minus f, and that is a inverse 1 by f is also periodic function. Okay, the period may differ, but both are periodic functions. Okay, now both are periodic functions. Okay. So, I hope that you understand these three concepts. Let us see some more concepts. Welcome to these two concepts. So, while finding the LCM of fractions, we will face somewhat difficult. So here one of the formula is there. LCM of A by B, comma, C by D, comma, E by F is there. Then the fractions LCM is equal to, first to find the LCMs of the numerator. LCM of the numerator you find out. Okay, now next you find out the LCMs of the denominator. First to find out the LCMs of the numerator. Next GCD, greatest common divisors of the denominators, BDF. Understand? Like that you can find out the LCMs of the fractions. Next one, constant function is periodic. Constant function is a periodic, but it does not have fundamental period. For example, take any constant function, f of x is equal to 2x plus 3. F of x is equal to some 2x plus 3. Sorry, constant function, f of x is equal to 7. It is a constant function. It is periodic. It is periodic. Okay. But does not have any fundamental period. Does not have fundamental period. It does not have any fundamental period. Why? Because it is a periodic clearly. So this is equal to y is equal to 7. Y is equal to 7 is a line parallel to x-axis. Y is equal to 7. As it is periodic, the straight line, it is a periodic. But it does not have any fundamental period. Why? Because we cannot define a certain interval in which the function is repeating itself. If it is a sine function, you can say that every 2 pi interval, so it is repeating. We can say that clearly the function is regaining its same shape. So this is a 2 pi, this is a 2 pi interval. Okay now, but for a straight line, it is a straight line, we cannot say a fundamental interval in which the function is, that is a graph is repeating. That's why a constant function does not have a fundamental period, but it is a periodic function. Every constant function is a periodic, but it does not have any fundamental period. Okay na? So I hope that you understand these two concepts. The first concept is, if any like that fractions are given, then you have to find out the for example, if you come across this, what is the LCM of 2 pi by 3, 3 pi by 2, some 6 pi by 7, like it is there. If you are asked to find out the LCM of 2 pi by 3, 3 pi by 2, 6 pi by 7, first to find out the LCM of numerators, that is 2 pi, 3 pi, 6 pi. Next GCD, commons 3, 2, 7. You know that LCM of 3 pi, 2 pi, 3 pi, 6 pi is equal to 6 pi. GCD, greatest common divisors of 3, 2, 7 is what? 3 2s are 6, 6 7s are 42. Total 6 pi by 42 is the answer for that question. Okay, na? So I hope that you understand these two concepts. Now let us see some very basic problems in this period of the functions. I have selected variety problems. Okay, na? So don't skip this video. Dear students, let us see the some problems here. So some variety problems I have taken. The first problem is, so the period of the function f of x is equal to x plus x by 3 plus x by 3 square plus x upon 3 cube, so on infinity. Then what is the period of this function? Okay, now. So if you observe here, so observe this angle, that is x plus x upon 3 plus x by 3 square x by 3 cube. First of all, x. In each term x is there. First take the x common outside. Let us see what happens. Cos of x common, 1 plus 1 by 3 plus 1 by 3 square plus 1 by 3 cube, so on infinity. Okay, now? Right. So clearly it is an infinite geometric progression. So 1 plus 1 by 3 plus 1 by 3 square, so on 1 by 3 cube. It is an infinite geometric progression. So we have the sum to infinity of the GP, that is a by r. A by 1 minus r. A means 1 minus 1 by r. What is the common ratio? Clearly 1 by 3. So this is 1 by 3. So therefore cos of This is 1 upon cos x of 1 minus 1 by 3 means 3 by 2. Okay, cos x of 3 by 2. Now, what is the period of this function? What is the period of cos x? This is a 2 pi. What is the period of cos x? 2 pi. What is the x coefficient? X coefficient is by 3 by 2. So, this is equal to 4 pi by 3. 4 pi by 3. So, therefore, the period of this function is 4 pi upon 3. Okay, now? So, the only thing is first idea what you have to get means you have to take the x common outside. Okay. Now, what is the period of the second problem? So, without any hesitation you can say that pi by 2. Why? Because already I have given first thing for cos, for sine and cos both have even powers. Both have even powers. And one more thing is both have the same coefficient. Both have the same coefficient, either 1 1 or 2 2 or 3 3. Therefore, its period is pi by 2. Sir, how can you say, sir? Yes, you write down in place of x put pi by 2 plus x. So, cos power 6 is equal to pi by 2 plus x plus sin power 6 is pi by 2 plus x. Then cos 90 plus theta minus sin theta, but power is there, sin power x. Cos 90 plus x, cos power 6. Again, you will get the same thing for pi by 2 angle only. Therefore, the period of that function is pi by 2. Okay. Now, coming to this type of trigonometric functions, so then how to find out trigonometric functions? We have given that sin x into sin 120 minus x into sin 120 plus x. Here may be 60, may be 120, may be 60, 120, 240, 300, whatever may be the angle here. Its value is 1 by 4 sin 3x. 1 by 4 sin 3x. 1 by 4, sorry. This is 4. 1 by 4 sin 3x. So, that means, now what is the period of this function? So, this is a 2 pi upon 3. So, for sine function, the period is 2 pi upon x coefficient is 3, 2 pi upon 3. Understand this? Okay. So, the only thing from this you have to observe is these three are three different problems. In the first problem, generally students are afraid, is there any function? It is there. So, first you take x common outside, infinite geometric progression you will get here. So, here it is a direct problem, sin power 6x plus cos power 6x plus sin power x, this is equal to pi by 2. So, here to do this type of problems, you should have already, I told, keep a separate notebook to write this type of functions, identities, result, so that the problems will be easy. Okay, na? I hope that you understand these three problems. Let us see some more interesting problems. Welcome to these three type of problems. See here, these are three different type of problems. Right? It is an exponential function. This is a fractional part function. So, this is a trigonometric functions. Let us see these three different types of problems. Let us see one by one. So, see here the first problem is 2 sin 2x minus 5 cos of 2x upon 7 cos x minus 8 sin x. So, whenever it is given this type of algebraic function, so you have to do what you have to find out. So, don't worry about these constants 2 minus 5 minus 8 7, forget about those constants, don't worry about those constants. You concentrate on the functions, trigonometric functions. What are they? Sin 2x, cos 2x, cos x, sin x. What is the period of sin 2x? For sin x period is 2 pi. For sin 2x period is 2 pi by 2, 2 will get cancelled, pi. Understand? So, therefore, the sin 2x period is pi. Same as cos 2x period is also pi. Cos x period is 2 pi. Sin x period is also 2 pi. That means find their LCM. LCM of pi comma 2 pi comma 2 pi is equal to 2 pi. So, what is the great least common multiple? What are the multiples of pi? Pi, 2 pi, 3 pi, 4 pi, 6 pi, 7 pi. What are the multiples of 2 pi? 2 pi, 4 pi, 6 pi. What is the least one? 2 pi. That is the answer. Okay, na? Right. Coming to here, f of x is equal to sin of e power tan x plus e power cot x. So first concentrate on this tan x cot x. That means if, for example, if we put x is equal to x plus pi by 2, what happened? Sine of e power tan of pi by 2. So here pi by 2 we cannot keep pi. Pi you keep, then only it will happen. So therefore e power tan pi plus x is equal to tan x, e power cot pi plus x is equal to cot x. Therefore the period is equal to pi. So here tan x cot x period is pi. Okay na? So tan x period is pi, cot x period is pi separately, and their LCM is also pi. Okay na? Now coming to this is a very, very important. Okay na? So here one more concept I have to explain. The period of fractional function, we call it as a fractional part function, is 1. The period of fractional part function. Already in chapter functions I explained what is a fractional part function. So this fractional part is given by x minus step of x. That fractional part of x is given by x minus step of x. Okay now. See here, in place of x 6x is there. In place of here step of x, here also 6x is there. So the period is equal to period of this function is equal to, what is the period of this fractional part of x? So this is nothing but, we can write it as fractional part of 6x. See here, x minus step x. This is the definition of fractional part of function. Same, in place of x 6x is there. In place of x 6x is there. So what is the period of this function? For fractional part, period is 1 upon, what is the x coefficient? 6. This is 6. So therefore 1 by 6 is your answer. Okay. So the period of 6x minus step of x is equal to 1 by x. Okay. I hope that you understand this solution. Let us see some more problems. Welcome to these type of problems. So here also I have selected 3 different models here. F of x is equal to secant of, observe here it is x degree plus x degree upon 4 plus x degree upon 16. See previous problem, there I have taken the first problem cos, it is x only, x plus 1 by 3 plus x by 3 plus x by 3 square like taken, but it is not x, it is x degrees. Okay na? So then how to do these problems? Let us see this. So that is equal to secant x is equal to x degrees. Take the x degrees common outside. So this is 1 plus 1 by 4 plus 1 by 6 plus so on infinity. Secant x degree into 1 plus 1 by 4 plus 1 by 16 so on. Okay now. So this is an infinite geometric progression. So this is an infinite geometric progression up to here. Its value is a by 1 minus r. A is 1, 1 by 1 by 4. This is 4 by 3. Understand this up to here? So this value is 4 by 3. Observe here, carefully observe here. F of x is equal to sin x, the period is equal to 2 pi, you are saying. The sin x period is saying 2 pi. Here x is measured in radians. X is measured in radians. Understand this. X is measured in radians, not degrees. Here x degrees is there. X degrees is there. Then how to convert x degrees into radians? This I started in the previous only I explained. So x degrees means what? X into 1 degree. Okay now. X into 1 degree means x into 1 degree is equal to pi by 180 radians. Pi by 180 degrees not. Pi by 180 radians. 1 degree is equal to pi by 180 radians. On the whole, this is secant. X degree means pi x by 180 into 4 by 3. Pi x by 180 into 4 by 3. So this is given by 4 ones are 4, 4 45s are. So therefore secant x is equal to pi x by 345 is 135. Okay now, right. Now what is the period of this function? What is the period of that function? For secant x, the period is 2 pi. The period is 2 pi upon what is the coefficient of pi by 135? That is a coefficient pi by 135. So pi will cancel 270. Don't write down degrees or nothing. 270 only. 270 only the value. Okay. So the very interesting problem. The x degrees. Always remember here sin x. Here x is a radians. That is equal to 2 pi. Okay now. That is equal to, here x degrees means x into 1 degree. 1 degree means pi by 180. So in place of x degree, pi x by 180 I have written cancellation. So on the whole, this is secant pi x by 135. What is the period of secant x? That is a 2 pi upon x coefficient is whatever may be that you divide with that x coefficient. X coefficient is pi by 135. Pi will get cancelled, 270. That's all. Don't try to put any degrees or nothing. That is a real number. Period is always a positive real number. Okay na? Right. Now coming to here, one more very interesting problem. So if f of x is equal to lambda modulus of sin x plus lambda square modulus of cos x plus g of lambda has the period pi by 2. It is given the period of this function is pi by 2. Then the value of lambda is. Already I have given yesterday's class some note points. What is the period of sin x, modulus of sin x plus cos x? What is the period of modulus of sin x plus modulus of cos x is pi by 2. Period of modulus of sin y, because in place of x, if you put pi by 2 plus x, that is modulus of cos x. If you put cos of pi by 2 plus x minus sin x, modulus of minus sin x means sin x. Okay na? So modulus of sin x plus modulus of cos x. Therefore the period is pi by 2. Here it is given already pi by 2. Therefore this value must be, see here, modulus of sin x coefficient is equal to how much? 1. Modulus of cos x coefficient is equal to how much? 1. Therefore this value lambda and lambda square value must be equal to 0. Sorry, lambda square value must be equal to 1, lambda value also should be equal to 1. Therefore, your lambda value should be equal to 1. Understand? Otherwise, plus or minus 1. Lambda value should be plus or minus 1. Either you can take plus 1 or even though if you take minus 1 or plus 1, nothing wrong in it. So, g of 1 or g of minus 1, it is a constant that won't harm our original problem. Understand this? So, very interesting problem. So, by seeing this, immediately you have to say that modulus of sin x plus modulus of cos x, the period is equal to 1. Okay, right. So, I hope that you understand these 3 problems. Let us see some more problems. Let us see the following problem. Here, the problem is, which of the following functions is not periodic? Here, 4 functions are there. 1, 2, 3, 4. Out of that, which is not periodic? Always remember that a periodic function should be linear. Should be linear. Linear functions only, they should be defined periodic functions. Why? Because in the fundamental definition itself, it is given f of x plus p is equal to f of x. F of x plus p is equal to f of x. In the fundamental definition itself, it is given that only the linear functions. What is the linear functions means what? The power of x should be equal to 1. The power of x or the degree of x or the exponent of x should be equal to 1. See here, what is the exponent of x here? Here 1, here 1. Therefore, it is periodic. What is the power x here? X power 1. Therefore, it is periodic. Of course, it will have some period. Afterwards, I will tell. What is here? X is there now. What is the power? 1. Therefore, it is periodic. But here x square is there. X square is there. What is the degree of x? 2. Therefore, it is not periodic function. Understand here? So the power of x should be 1. Here the power of x should be 1. The power of x should, whatever may be that, if it is in the cos of or sine of or root, whatever may be that, it is a okay. Otherwise, we can convert it into linear. For example, you may ask one doubt, sir, if it is a f of x is equal to some cos square x is there. Sir, is it a, for f of x is equal to, sorry, cos square x. Okay, we can, but we x square, cos x square, it is not periodic. Cos x square is not periodic. Remember here, f of x is equal to cos square x is periodic. Why? Because here x power 1. Whereas f of x is cos x square is not periodic. Understand this? So that means if the power of x, whatever may be that x variable, whatever may be the function, x power is there, no, that should be 1. If it is more than 1 or less than 1, it is not a periodic function. Therefore, period does not exist. Okay. I hope that you understand this concept. That is, the function should be linear. Linear means the power of x should be equal to 1. Such type of functions only periodic. Okay, na? I hope that you catch this point. So let us see some more problems. So let us see these two problems. F of x is equal to step of sin 3x plus modulus of cos 6x. Okay, now type. What is the period of these functions? First, what is the period of this function? This is for sin 3x, 2 pi is there upon x coefficient 3. Okay, 2 pi by 3. What is the period of modulus of cos 6x? Modulus of cos 6x, I have already told, modulus of cos x period is pi only. Modulus of cos x period is pi only. Therefore, modulus of cos 6x means pi by 6. Pi by 6. For this, you have to take the LCM. Then, here the students will get confused here. Sir, how to find out the LCM of 2 pi by 3 comma pi by 6. Here what is the numerator? 2 pi. Denominator 3 pi. Here numerator pi. Denominator 6. For numerator terms take LCM. That means LCM of 2 pi and pi divided by. For denominator terms take the HCF or GCD. Both are same. That is a GCD or HCF. HCF of 3 comma 6. Understand? See here, whenever you are getting this type of fractions, first for numerators find out LCM, for denominators find out HCF. So if you want to find out HCF by LCM. If you want to find out LCM by HCF. Okay, na? Right. So automatically we will get the answer. So what is the LCM of 2 pi comma pi? It is a 2 pi. What is the highest common factor of 3 comma 6? What are the factors of 3? 1, 3. What are the factors of 6? 1, 2, 3, 6. What is the highest common factor? 3. 2 pi by 3 is our answer. Understand this? Coming to the next problem. The problem is f of x is equal to step of 6x plus 7 plus cos of pi x minus 6x. How to find out this period of this function? See here we have one concept, that is a step of x plus k is equal to step x plus k, where k should be an integer. Where k should be an integer. If it is an integer, we can take it outside of the step. That is equal to 6x plus 7 plus cos pi x minus 6x. Okay, now? Right. Let us combine these two. That is equal to step 6x minus 6x. That is, we have that one. Fractional part of x is equal to x minus step x. X minus step x. That means, okay, I can write it as minus of 6x minus step x. Can I write it as plus cos pi of x plus 7. Okay, now? Right. What is the period of this? So that is minus Frowell bracket 6x plus cos pi x plus 7. That is the fundamental definition. Fractional part of 6x is equal to 6x minus step of x. That is x minus step of x is nothing but fractional part of x. That is 6x minus step of x is equal to fractional part of 6x. So, what is the period of this function? Okay, now, so this period is equal to 6x. So, 6x period, so that means 1 by 6. LCM of 1 by 6, cos of pi by 6. Cos of pi by 6 means how much? Already we know that for cos x 2 pi by pi. Pi pi will cancel 2. Okay. So, 1 by 6 comma 2. Find their LCM. Just like how I explained in the numerator, you find out that period that we will be get. Okay. You will get the, so numerator LCM and denominators LCM you can find out. Denominators highest common factors you will get the answer. Okay, now. So, dear students, I hope that you understand today's class. Tomorrow's class I am going to explain the maximum and the minimum of all these trigonometry functions I will explain. Okay, I hope that you enjoyed today's class. Let us see the tomorrow's class.